Bismillah ar-Rahman ar-Rahim. Breathing and scavenging systems. The first system is the open system, which is the simplest system, where there is no tubing, valves, or reservoir bag. This figure shows the three forms of them. First of all, what we call the cupped hand, which is used by the pediatrician, which he administrates the oxygen through the tube. And this was used before by the Schimmelbusch mask, which was used in anesthesia. The second figure shows the Edinburgh mask, which has a wide orifice, which of course minimizes the dead space. And the third figure shows the cannula administered to the nostrils, or can be administered to the mouth through a gauge, special gauge. The drawbacks of the open system, of course, there is little control over the concentration of oxygen or other gases. Dilution is inevitable. And during peak inspiration, which is around 50 liters per minute, this is the amount which is being used sometimes by the patient, cannot be satisfied by this system, because the patient definitely will take air from the surrounding, unless we have a fit using a Venturi mask, as we know before, which can give us the amount of aeration required by the patient, which is the peak inspiration, or using a tightly fitting mask or intubation. The second system is the non-rebreathing valve system, represented by the Ambu-E valve, as we can see. It's made of two flaps, inspiratory, expiratory valves, or having flaps, and they are molded, and of course they are inspiratory expiration, and can be used for also controlled ventilation. The Quantiflex, which was used in the dental surgery, is similar to a non-rebreathing valve, and it has the valve nearby the bag. The second device is the Ambu E2 system, which is in which the expiratory flap is omitted. It's used in resuscitation, so we cannot consider it as a non-rebreathing valve system. The drawbacks of the system that the inspiratory flap may stick, develop very high pressure, around 100 to 200 Pascal. Of course, whenever I want to change it to centimeter, I divide by 100. During peak flow, of course, it's uncomfortable for a conscious patient. This is why we use special low resistant valves, as that used in the anti-NOx, or used by the airmen or firemen and divers. Of course, in rebreathing valves using in the anesthesia, we can use what we call the one of the offshore miniature vaporizer, which is the tri-surface apparatus. It's a draw-over vaporizer, where the inspiratory and expiratory flaps are incorporated in what we call Dirdal valve. As you can see, it is considered a non-rebreathing system. And of course, we can administrate oxygen through this T-piece part. Now comes the T-piece system. As you can see from the figure, it has an expiratory tube, and we have an inspiratory limb introducing the fresh gas flow, which is around, it ought to be around from 2 to 2.5 times the normal tidal ventilation, so that we will assure that there will be no rebreathing. What happens in this system? During expiration, we can divide the expiratory limb according to the constituents of the gas in it into 4 parts, as you can see. The first part, which is A, this is the part during expiration where it contains the the dead space air. And then after that, we have the area B and C containing the alveolar gas, and then the C, which contains part of the alveolar maybe or no, and some of the flow from the inspiration, as you can see. So whenever the patient has an expiratory pulse, definitely this area will contain only the normal inspiratory fresh gas flow. The system was developed by Philip Early, 1937. So there is no valves, and it has to have a suitable diameter, 21 millimeter, as we know. The volume of this expiratory tube ought to be equal to the tidal volume of the patient. And as we said, the tidal ventilation ought to be twice or two and a half times of the normal tidal ventilation of the patient. And the capacity of tube, as we said, ought to be the capacity of the tidal volume of the patient. Of course, different, as we said, if there is an expiratory pause, for instance, is around 1 second, instead of using double the tidal ventilation, you can use up to 8.5 liter of minute to assure that this area D will not contain anything apart from the inspiratory flow. So this is what we call the 1 second expiratory pause, which assures us that the patient will not rebreathe the previous expiration. Of course, the presence of the bag definitely also diminishes the amount of requirement gas. Of course, it's used in pediatric anesthesia because there is a negligible dead space, and of course there is no valves, and hence the problems of sticking of the valves. But the problem that there is we ought to use high fresh gas flow on, of course, and we can prevent pollution. We will show the pause in the next slide. This is a diagram showing the expiratory pause. As we know that the respiratory tidal volume supposes 400 milliliter, and the rate is 12, so that the period of respiration is around 5 seconds divided by inspiration expiration. As we can see, using more than double the tidal ventilation, around 14 liters per minute, assures us that there will be no breathing if there is no expiratory pause. You see, so if it is begins from the inspiration, this tidal ventilation will assure you that there is no rebreathe. But if there is an expiratory pause around 1 second with it, we can use 8.5 liters per minute, minimizing the rebreathing system, and where the patient will not take from the expiratory valve. The second, the second system followed is the coaxial TP system. Is similar to the TPs, but they are coaxial. That means an expiratory tube is inside the expiratory limb. Of course, there is a bag and there is a valve. Of course, this also needs around 2.5 times the tidal ventilation to assure not giving or not using the rebreathing system. Take care, of course, of the central tube not to be detachment, otherwise the dead space will be increased. The McGill system, as we can see, it's made of a fresh gas flow and a bag and an expiratory valve nearby the patient. Of course, this respiratory valve, expiratory valve, I'm sorry, could be removed from the patient, as we can see. What happens? What happens? First of all, the patient during expiration, the dead space air is moved toward the end of this expiratory limb, and then followed, of course, by the alveolar. The pressure of the bag during the inflation of it by the inspiratory flow assures that the valve will open at around 50 Pascal. At the time, the alveolar gas present in the expiratory will be dismissed. So this assures that the patient can use during spontaneous ventilation 70% of the patient's tidal ventilation. This is the importance of the McGill circuit. Of course, whenever I tighten the valve and I can use it as a controlled ventilation, the system loses its advantages as using 70% of its tidal ventilation, but we can use it for only short periods for controlled ventilation. The coaxial McGill system, as we can see, is similar as the T-piece, coaxial T-piece, but the inspiratory limb is the one outward, you see. So we have the expiration tube reaching the expiratory valve, and the inspiration is surround this tube. Of course, the patient, the problem that the patient is breathing from the two tubes. So this tube ought to be of a large, wider level, so that will not exhaust the patient during expiration. Now we come to the closed circuits. Of course, as you can see that we have an expiratory limb. We have the soda lime system, which the patient rebreathes through it to get rid of the carbon dioxide. The mesh size, it ought to be at the proper size, large enough to avoid the resistance, and small enough to assure a proper efficiency. And we call it 4 to 8 meshes. What does it mean? It means that if I get a 1-inch strain and I divide it into 4 parts, it will not allow the passage of these particles. And if it reaches 8, it will allow. So we call it that the proper size is between 4 and 8 to assure the proper function of this soda lime. Of course, this, as we said, the vaporizer could be inside the circuit or outside the circuit, like that occurring during our practicing of anesthesia. Of course, inside the circuit, it uses the simple draw over vaporizer, where the vaporizer receives the expiration of the patient with its water vapor, minimizing, of course, heat loss than that of the vaporizer outside the circuit, which needs a competent vaporizer. The drawbacks of it is, of course, difficult to sterilize this system. And we ought to have analyzing a system for the concentration of the gases. Of course, it will be costly. Of course, as we said, the heat loss can be minimized by the expiration of the patient. Of course, it reduces, of course, the pollution of the circuit. Sometimes whenever I use 2 liters per minute, we admit some sort of leak. This assures that the concentration of the gas reaching the patient is not affected. So we can call it as a closed system with leak. And if it occurs, it will be deprived from the advantage of the closed circuit. Of course, at the beginning of anesthesia, we ought to use this system with leak to get rid of nitrogen, to control the nitrous oxide concentration. This is what we call the denitrogenization before at the beginning of the system. Alternative classification of the system, of course, the system according to Mapleson is divided into five categories. This system does not include the closed system or the non-breathing system or the open system. The first system is McGill system, as we know, the bag and the valve by the patient. The second and the third one, or B and C, are omitted because they are not useful. Where the inspiratory, I'm sorry, the fresh gas flow is being administered before the expiratory valve. Whether in B we have an expiratory limb, or in C we are devoted. There is no expiratory limb, only it's attached to the bag. And then we come to the D system, which is the iris TPs with a bag and a valve, and then the F system TPs. So the T piece without a bag, and then the last one is the T piece with a bag. I'm sorry. Now we come about resisting of breathing system. As you can see that the resisting in an open system is minimal because there is no tubing or valves. And to assure a proper flow, of course, as we know, the laminar flow is accomplished whenever the size of the tube is smooth, around 22 millimeter of diameter, with a flow of less than 22 liter per minute. And the absence, of course, of corrugated tube can assure us that the flow is laminar. As we know, the resistance is inversely proportional to the force power of the radius. This is why the tubes ought to be around 22 to 30 millimeter by giving a 3.5 times reduction in the resistance. Of course, the typical valve has an opening pressure of 50 Pascal, as we said before, by a 30 liter per minute of flow. So this is the optimum pressure at the valve. Of course, turbulence will occur if the pressure at the valve is around 100 to 500 Pascal. And of course, the reverse, the reservoir bag can affect the pressure which develops during spontaneous breathing. Now we come to the work used in the breathing system. As you can see, we applied 400 milliliter of gas to the patient and record the pressure at the connection. And we draw the area of pressure volume loop through different types of system. We can find the inspiration and the expiration. As we can see, this is the inspiration, which is dotted, and this is the expiration, moving, making loops around the 0 point, as we can see. And this is a different size or types of breathing system and their loops. Now we come to what we call the component system of. I'm sorry. Sorry, we passed this one. Safety of breathing system, of course, we have to be the cross system ought to be assembled, and where the components must match each other, and using screw collars. Of course, we have a female and male, and we can have a taper gauge to assure the proper fitting. Of course, the plastic containers are affected by autoclaving. They ought to not to be too narrow or having sharp angles, otherwise the flow will be turbulent. And the bag ought to have a proper elasticity. As we know, the pressure equals 2T over R, as regarding Laplace law. So to keep the pressure constant, whenever the radius increased by the inflation of the bag, the tension ought to be increased at the similar ratios to keep the pressure. This is the character of the elasticity of the bag. So if the bag is not well elastic, it will affect the final pressure, giving very high pressure. So this pressure, which is around 4 kilopascal, of course, when I want to transfer it to centimeter, I only I multiply by 10. You see, so this assures us that the pressure will not last for long time till I find the problem and solve it. Of course, the expiratory valves position nearby the patient definitely decreases, minimize the anatomic dead space. And of course, we must take care of the central tube in the coaxial system not to be detached. Of course, whenever I have an inspiratory and expiratory valve, these two valves increases the resistance. So this is the importance not to have these valves to minimize the resistance. The resistance is increased in the suppose in the system where there is only one valve as the expiratory valve, because this resistance increases during expiration, because the patient ought to expire against a flow coming from the back and a fresh gas flow. A hint about the ventilator. A ventilator, as we can see, the manly pulmovent ventilator, where we administrate 7 liters per minute, and with a pillows given by the spring, of course, the pressure of 10 to 12 kilopascal. This we call it a preset volume. So by a lever system, this volume is being administered to the patient, but there is a special valve that controls the pressure to limit it to a maximum of 7 kilopascal. So this valve limiting pressure makes the system confused. During expiration, this system is transferred to a T system method during spontaneous, ventilation. Of course, the tidal volume is measured by the right respirometer. Sometimes the pulmovent has an extra pillows to induce a negative pressure, as was used before. Of course, we have to sensor pressure for the high and the low pressure to protect the ventilator and the patient from high pressure. Ventilator, this is why they are divided into constant pressure generator or constant flow generator. The near constant pressure in this type of ventilator is generated and applied by a flow control. So the pressure and the flow are confusing regarding the classification of this ventilator. Nowadays, of course, most ventilators use pressure and flow or volume control system to modify the function of this ventilator. The scavenging system, of course, in the past, they used to claim anesthetics for the incidence of abortion, but this is not considered proved. Of course, we have an active one and a passive one. The passive one, as you can see, it depends upon the expiration force of the patient, but the active one uses a pump or a device similar to assure the scavenging occurrence. Of course, with the system, of course, could be a simple one or advanced one made of different parts, as you can see. Made of transfer and receiving and disposable system. apart from the simple one. See, so as you can see, the open system, we have a funnel applied to the expiratory valve or applied to the patient directly, or it can be inverted, attached to the end tube of the TEPs. Of course, all these are have a lack of control, and we ought to have high scavenging fluid is needed. And of course, these funnels ought to be very close to the patient. The component system, as we said, standard technique. We have the exhaust going through this receiving system ought to be around 30 millimeter of size, made of a female and a male connection. It goes after that, this exhaust part to the disposable, the receiving system, which is made of, as we can see, an open-ended reservoir, as we to prevent the high pressure, or we call it air leak. And then after that goes to a disposable system made from a fan or a pump. Of course, this fan to minimize the incidence of pulmonary edema, but of course it could occur with fans also. So this assures that the pressure not to exceed 50 Pascal. Of course, the passive scavenging system is affected. Of course, the port outside is affected definitely by the wind movements. If it is above the roof, of course, the dense anesthetics as nitric oxide could be returning back. This is why we use an exit grill to minimize this effect. Of course, the theater ventilation is important to get rid of all this amount of disposed anesthesia, which occurs at the end of the anesthesia or at induction, or by using face mask. So we must have a circulating of around 15 air change per hour to avoid or to minimize the effect of pollution from anesthetic volatile materials. والسلام عليكم ورحمة الله وبركاته.